Hi everyone. This term in our chemistry investigation, we are going to try and separate copper metal from a copper ore. It's an imaginary copper ore that's been prepared for us prior to the lesson. Here's an image of the copper ore with a couple of common items to give us a sense of perspective. We're going to use an electric balance. I'm going to try and figure out exactly how much ore we've got using subtraction. First, we look at the beaker that we're going to have to hold the ore in. We transfer some ore to the beaker, and the difference between the two is the amount of ore that we have. We get some hot water, we put it into the beaker and we allow the ore to dissolve, give it a little bit of a stir, allow it to dissolve for a good 5 minutes, so that hopefully all of the copper compound that is inside the ore will dissolve into the water. So now we have a suspension. The insoluble part of the ore is suspended in our solution, and we want to separate out the solution from the insoluble part of the ore. We're going to use filter paper, and this part of the video is to hopefully remind you of how to set up a filter paper. We fold it in half, and we fold it in half again, and then we open up the side of that piece of filter paper to make a cone, which we're going to place into our funnel. We want to separate out the solution, which we believe contains our copper compound, from the sediment. So we give the suspension a chance to deposit into a sediment, and then we decant our solution into the filter paper, being very, very patient and careful not to allow the solution to move up over the edges of the filter paper. When we've successfully separated out our solution, we turn our attention to the electrolysis. We look at our copper electrode. We find the mass of our copper electrode before we run the experiment. It's 1.24 grams. We take note of our lead electrode, and that's running at 24.94 grams. Using steel wool, we polish the surfaces of both of our electrodes to get them nice and shiny. There's the copper electrode, and now I'll show you the lead electrode. We then attach the copper electrode to the negative terminal of our power supply. We attach the lead electrode to the positive terminal, and we let the electrolysis run at 4 volts for 15 minutes. I went for 25 minutes just to be sure. Now that the experiment is complete, we look at our copper electrode again, and we see now that it's operating at 1.27 grams, which is 0.03 grams more than it was at the start of the experiment. The lead electrode doesn't seem to have changed. We can use a percent calculation to try and figure out the percentage of copper metal in our original ore sample. Our copper electrode increased in mass during the 25 minutes of electrolysis by only 0.03 grams. The ore itself came in at 5.99 grams before the experiment. This leads us to believe that the copper metal in the ore was 0.5%. This is dramatically less than the 10% that was intended in the preparation of the ore. The next question as scientists that we have to follow is, well, where could we possibly have gone wrong? What sort of mistakes might we have made? I ran the electrolysis for 25 minutes, but it seemed that there was a reaction occurring as soon as I started the electrolysis, and it didn't seem to change for the entire 25 minutes. So I wonder if I gave enough time to remove all the metal from the solution. I also know that in the instructions I was told to add salt to the solution to improve its conductivity, and I forgot to do this. So I wonder if that had an impact on my experiment. If time was permitting, I would run the experiment again with the salt in the solution and give it a lot longer in the electrolysis stage to see if that made a difference to my results.